So today we're going to find an alternative way of finding slope using what's called the slope formula. So there is another way other than just calculating rise over run where you can find the slope. And in some instances, this is going to be a better way. For example, if you have a rise of 1,600, you're not going to want to count up that many squares. Same with your run. If your run is more than 100, that's going to take you a long time to solve a problem. So there's another way. So if you look at this example, multiple representations. In example 1, part A on page 643, you saw how to find the slope of the line by finding the ratio of the rise to the run between any 2 points of the line. You can also find the slope of a line that passes through the points x1, y1, and x2, y2 by using the slope formula. We remember that slope is the change in y over the change in x. Well, what is that change? The change is the difference. So you can take any 2 points, and instead of calculating the rise over run, you can subtract your y's and your x's. So there's a few things that you really need to remember when doing this. So the first step that we need to do is to look at the 2 points. So we have 5, 4, and 1 and 2. It really doesn't matter the order where we start, but it does matter that you're consistent with where you start. And I'll show you what that means. So in this case, I think it's a lot easier to start with the larger numbers because when you subtract a larger number and a smaller number, most of the time students find that easier. So that's what we're going to do. So first I'm going to rewrite my 2 points. So I had point 1 and 2 as well as point 5, 4. And these were both positive, so that makes the problem a little bit easier. So then I have to decide which expression do I want to start with first. So in this case, I'm going to start with my larger number. If you started with a smaller one, it would be just fine, but you would get negative answers. So let's look at these. We have 5, 4, and 1, 2. So I need to remember the slope is the change in y over the change in x. So that means y1 minus y2 over x1 minus x2. And that just means you're subtracting each of the y's and each of the x's. So we'll call this 1, and we'll call this 2. So this is going to be my x1, my x2. This is going to be my my x2. My y2 is on the left, and my x1, y1 is going to be on the right, because again, I wanted to start with the bigger numbers. So this is what I mean by needing to be consistent. You have to start with your y. So we have 4, that's my y1, minus my y2, which is 2. So 4 minus 2 over, and again, I have to be consistent, x1, which is 5, minus x2, which is 1. Now I have a simple subtraction problem, and then I'm going to get my slope. 4 minus 2 is 2. 5 minus 1 is 4. So my slope is 2/4 or 1/2. So this is an alternative way of doing rise over run, and in many instances this is going to help you. I want to go over one extra problem just to make sure that there's no confusion. So let's look at this example where we have just points that we have that are not on an actual graph. So we have to use the formula to solve the expression. So we remember that slope is change in y over change in x, or y1 minus y2 over x1 minus x2. And in this case, I'm just going to go from left to right. Again, it really doesn't matter which one you choose first as long as you're consistent. So we're going to call this our x1 and y1, and we're going to call this the second one our x2 and y2. So let's start with our y's. So I'm going to circle those in yellow. My two y's are 2 and 2. So notice that we have the change in y first. So let's start with x1, which is 2, and coincidentally, our y1, which is 2, and our y2, which is also 2, over our x1 and x2. So let me circle those in purple. Now we are looking at our x's, and again, I have to start with this side. -2 minus 3. Well, the numerators are hopefully very easy for you. 2 minus 2 is 0. -2 minus 3. Remember our same change rule when subtracting negatives? This is the same as -2 plus, change the subtraction to plus, and change the +3 to -3. So 2 negatives plus 3 more negatives is -5. Now, this, of course, is a slope of 0 over -5, which means that my slope is just 0. Another thing to note is you don't ever want to get 0 on your denominator because that is undefined. You cannot divide by 0. So make sure it's okay to have it in the numerator, but not in the denominator. So in this case, our slope is 0 because we have the 0 in our numerator. So I hope that helps you out, that formula. And a good thing to do is to always just label what you want to be your y1 and x1 and what you want to be your y2 and x2. That'll definitely help you.